All right, guys. Looks like it's admittance into the lobby is slowing down. With that, I'm going to get us started kind of on time. Want to thank everybody for attending today's Thursday edition of Friedrich Product Training. Excited to have Pete Iadachi, our Director of Technical Management, on today to talk about VRP technical troubleshooting. We are recording this webinar, so I would appreciate if you would hold your questions until the end. We will allow some time for Q&A. And with that, Mr. Iadachi, the floor is yours.
Hey everyone, welcome to Friedrich's VRP Technical Troubleshooting webinar. My name is Peter Didachi and I'll be going over the process of troubleshooting the VRP and the support that we have to offer here at Friedrich. The VRP is an amazing machine, but it's quite daunting when you first start. So we put these slides together to assist you when you run into issues in the field. Some housekeeping items, be sure to hold your questions for the Q&A session. You can also type in your questions in the chat box and we're going to try and answer them as we go along. Okay, so let's go dive in. In our national VRP trainings, one of the things that we cover is the VRP troubleshooting map. And the VRP troubleshooting map covers reviewing the design, checking the application, verifying the installation, and then troubleshooting the system. In the last part of this series of webinar, we're going to go over the troubleshooting portion of this map. Now, in previous sessions that we had in webinar, we went over about how to review the design, to check the application, and to verify the installation, and to avoid some of those pitfalls mentioned inside the best practices class. Once you have gone through all those steps, then it's time to troubleshoot the system. But there's a very important step that has to be done before you guys even attempt to troubleshoot the system, and that's ensure that the proper startup was done on the property. The VRP startup program, as we explained, is a process that we use here in Friedrich to ensure that the equipment is installed properly. So as you start to go through all the phase documentation of the VRP startup program and you start to enter the startup phase of the program, one of the things that you can easily check off your box is that the installation is done correctly. So before we even get to troubleshooting, we definitely want to make sure that it's installed correctly. But by the time you get to this step, if all these steps are done beforehand and they're done correctly, this will be an easy step to bypass. So while starting up or after starting up, you get equipment issues, then it's time to get to the troubleshooting section. So let's take a look at some of the tools that we use to troubleshoot the VRP. So first, the best tool is probably going to be your judgment. So we have a disclaimer to use your best judgment at all times regarding personal safety. So if the unit is powered on and you're inside a tight closet and you don't feel safe reaching across the MCS board or carriage 460 volts DC, we recommend that you don't do that. You need to power off the machine in order to properly troubleshoot it. As far as the tools are concerned to troubleshoot the VRP, obviously you're going to need a meter, but some specific things about a meter that you're going to need. You're going to make sure that your meter is capable of doing AC volts up to 500 volts, DC volts up to 600 volts, and then ohms up to 10,000 mega ohms. You're also going to need some needle point test leads. This is going to be extremely handy when back probing a lot of those Molex connections and ports that we have on our boards. Now, worst comes to worst, if we need to verify something with a charge or if we need to verify something with the pressure, at that point, we would then ask to attach a 410A gauge manifold onto the VRP. Now, remember, the VRP is critically charged. So anytime that you put any sort of hoses onto it, you're going to be removing that charge. So it's very important that we understand that. If you do happen to have access to a VPXWC wall controller with a 3x Molex, with a 3-foot Molex whip, this can help to identify things such as firmware and pull error codes without having to open up the unit. As far as skills are concerned, there are 6 required skills for troubleshooting the VRP. The first one is patience. Revolutionary digital communicating technologies replace older analog components. So communicating digital technology is registered in DC voltage and not AC voltage. So it's very important that we understand how that technology works. Coincidentally, the second step is also patience. Get a pair of needle point meter leads. This is going to save you a lot of time and frustration when you need to back probe a lot of these Molex ports or connections, especially if you're inside a tight closet. And of course, step 3 is also patience. Is to know who to call when you need help. When you've exhausted all of your options and you need some advice, we're going to get to who you would need to call in order to get the proper troubleshooting steps that you need. So the fourth skill is observation. There are a lot of LED indicators on the MCS board and the FMC board, and they all correspond to unit operation. And sometimes being able to interpret those lights will give you a pretty good clear indication of where the problem is and where you need to go. The fifth skill is electrical tracing. So we're no longer using 24-volt AC systems. We're now replacing them with 5 to 10-volt DC systems. So being able to trace where the power goes on the boards, especially with the sensors and the thermistors, is going to be a great benefit to you. And then lastly, the sixth skill is the DC communication. So DC communication is now becoming very prominent inside the HVAC industry, and we need to understand how the DC voltage is interpreted into values, and about how those values correspond to the VRP's logic and how it makes it respond. So the troubleshooting method we use at Friedrich Air Conditioning is simply called the rule-out method. The rule-out method has 3 steps in it. It has a probability diagnosis, and then ruling out each one of the components, and then a true certainty diagnosis. So to go over them really quick, the probability diagnosis is the act of ruling out and understanding certain components based on experience and simply watching and observing the system operate. So a good example is you set your VRP to cooling, and you would expect the outdoor fan to come on, and then you expect the compressor to start. So when those events don't happen, then we can start to say that probability diagnosis, and maybe something with the fan, or maybe something with the compressor, and we need to start to rule those components out. So when we get to the actual step of ruling out the components, it's the act of understanding how they operate and maintain their logical sequence of operation, where failure to produce expected results occurs. So as you're sitting there watching the unit and you don't see the outdoor fan start and you don't see the compressor start, you're going to say, okay, there may be something going on with the outdoor fan, there may be something on the compressor. I need to rule out each one of those components, because at this point they should have started inside their logical sequence of operation. And then the true certainty diagnosis is the act of proving a condition exists or existed by testing and acquiring physical and empirical evidence which caused or is a result of that condition. So it turns out that you decided to get an ohm value for your compressor, you decided to get an ohm value for your outdoor fan, and both of those turn out to be okay. And then we come to a true certainty diagnosis that it is the driver of those components, which is the MCS board, which is not operating properly, which is the reason why your unit isn't operating. So let's start to take a look at a couple of examples. One of the things a VRP is going to do is that if it can't operate or it can't run for any reason, it's most probably going to flash you an error code. So the error codes are located on the FMC board. It's the board that's all the way in the right inside the electrical compartment. Notably has 3 green LEDs that are inside the center of the board right above the SD card. So for any particular reason, if the VRP can't run and the system senses that there is a problem or it is in trouble, it's going to flash you a code. These diagnostic codes come in a series of blue and red LEDs. So the blue is a value of 10-digit and the red is a value of 1-digit. So the example we have here is that if you see 4 blues and 3 reds flash, that would be an error code 43. So if one or more code is active, what the FMC is going to do is it's going to flash your first code, give a short pause, and if there is another code, it's going to flash that code. And then if that is the last code that it is telling you, it's going to give a longer pause and it's going to repeat the sequence. An obvious step here, we want to make sure that if we see no power on our boards, we see no power on our wall controllers, we definitely want to make sure that their power is going into the unit. So we want to make sure that the service switch is inside the correct position, and we want to make sure that we do have power to the unit. So if it does turn out that the switch is in the correct position and you don't see any lights on the board, probably the first thing you want to do is put your meter leads on the terminal block to ensure that you have proper power going to the unit. If not, we want to trace to figure out why we don't have power going to the VRP. So the diagnostic codes, or the error codes, can be divided into 3 basic categories. So troubleshooting these categories uses pretty similar steps or processes in order to figure out what the actual problem is. So we're going to go over each category one at a time. And then we're going to go through some of the we're going to go into a little bit of a dive into those codes in that category. So temperature based, we're talking about sensors. So we know that sensors modify the DC voltage and are interpreted through the FMC. So the errors indicated a possible issue with the sensor or the FMC, or the sensor has determined an abnormal condition, or that the condition that it's sensing is out of the parameter value. So in other words, that if a sensor is sensing that the room temperature is negative 282 degrees, that's obviously an abnormal condition and it can't be possible. So at that point, we want to see it. We want to rule out we want to rule out the sensor, and then we want to take a look at the FMC to see if there is a voltage problem there. When looking at voltage and amperage, so this is the incorrect voltage or power fluctuations may trigger codes, but will resolve when voltage is brought within specification of parameters. These are sometimes called soft codes. Over amperage codes may indicate a motor failure or MCS, motor driver failure, or onboard IPM failure. So the idea here is that one of the components has flagged the board that there is something going on either with the voltage or the amperage. And the process they we're going to use is that we want to rule out the motor, and then if the motor is fine, we're probably going to look towards the board. Finally, it's a configuration or a communication fault. So there are 3 boards inside the VRP. So you have the FMC, the MCS, and the heater board, and they all communicate via ribbon cables. So if the communication is dropped or lost with any one of those boards, VRP won't operate. And these codes also populate if there's a software, firmware, or a logic failure, or finally if there's something going on with the indoor fan. Taking a look at the temperature-based diagnostic codes, there's a couple good tips here. So the first one is that the VRP sensor banks contain 10 sensors for air and coil feedback. Each one of those sensors is a 10 ohm resistor, and it must be unplugged from the FMC to test it against a resistance chart. All of the sensors have a 2 plugs Molex connection, and they all share a common power supply, which can be checked against each other for the other connectors for continuity and to rule out the FMC. So anytime that we get a sensor error, probably the first thing that we want to look to is the sensor to make sure that it is calibrated correctly. So being at the 10,000 ohm, you can use a 10,000 ohm resistor chart to see kind of where that sensor should or shouldn't be based on the ambient temperature that it is. If the sensor is easily accessible, you can remove it. You can put it in an ice bath to make sure that it is the proper ohm value at about 32 degrees Fahrenheit. If not, we wanted to assume that the sensor is probably good. So one thing to important note is that the VRP will only give you an error code if that sensor is shorted. So you're getting shorted, 0 ohms, or open. If the sensor is out of range, it's not going to give you an error code. So my example of let's say the indoor ambient sensor picking up negative 282 degrees Fahrenheit, it's not going to give you a error code saying that that sensor is open, although it may give you a different error code responding to the condition where that sensor is. So the first thing that we want to do is once we rule out that the sensor is good, we definitely want to rule out the pin connectors on the FMC. So the first pin in each set of the colored Molexes that we have here can be checked against each other in continuity. So power goes into the first pin of each set. So probably the first thing that you want to make sure on that particular sensor that you're having an issue with is that you actually have power to that. So you could do that by turning off the machine and doing a continuity test between the adjacent first pin and then the pin of the sensor you're having an issue with. So once you know that you got continuity there, the next thing you can do is you can turn the unit on, and once it gets to a stable state, you can go and unplug the sensor, and you can probe that pin correct, and you can probe that Molex pin directly. So that Molex port with it unplugged, set your meter to DC voltage, and you should have roughly 3.3 volts coming out of that port. So earlier this week, I troubleshot a bad sensor with a manufacturer's representative, and it turns out that it was getting a certain error code. We ohmed out the sensor. The sensor appeared fine. We went to the board. It turns out that the pin connector was only putting out 0.8 volts DC. All right, so now let's go over some of the temperature-based diagnostic codes, and we'll briefly get into a few of them. Some of them are self-explanatory. We'll just kind of graze over those, but I think that the ones that are most important, those are the ones that we're going to really hit on. So error code 14 is probably one of the better ones because it is in regard to the pressure switches. So the VRP has a high and low pressure switch, and these pressure switches are wired in series. So if we lose any of those pressure switches or they go off, it's going to shoot you an error code 14. So both of those switches on black connectors, on the yellow and the orange wire. Error code 19, outdoor coil over 190 degrees. Obviously, the sensor on the outdoor coil has detected that it's over 190 degrees, and there's obviously something going on there because that coil is getting extremely hot. Error code 20 and error code 21 are pretty self-explanatory inside the same way as that if the indoor coil is under 30 degrees for 5 consecutive minutes, there's probably something going on with the charge. And then if the unit cycles too often, which is a code that I have yet to see, it's basically telling you that the unit might be oversized for the space. Error code 23, room freeze protection. There's something going on with the T8 sensor. So most probably where you want to look to if you get this error code is the T8 sensor, and just verify that it's working, and then double checking the MCS board as we said before. So discharge air over 185 degrees. This can possibly be when the indoor blower is not operating and the electric heat is on, or there's something going on with the electric heat switches and they're not cutting it off. So same process here. We just want to confirm that the outdoor sensor is doing its job and what it's supposed to be, and that the FMC is also putting out the proper voltage. So this one is also an interesting code because the second you turn your unit on, if it's inside ambient condition and no blowers are running, and you immediately get an error code 24, you can almost assume that there's something going on with the sensor or the FMC board, because the condition can't occur of over 185 degrees if there's no motors running. Same thing goes for error code 26, indoor temperature beyond operating temperature. So it's telling us that if you get an error code 26, the indoor temperature is below 32 degrees or above 130. Obviously, if we're standing inside a room and it's 70 degrees and it's 90 degrees out, and we're getting and populating an error code 26 right off the bat, we could almost say that there's something going on with the sensor or the board, and we definitely want to check those out. Troubleshooting voltage amperage related diagnostic codes may come down to simply, is it the board or is it the motor, right? So unlike PSC compressors and PSC motors, when something happens to a inverter piece of equipment that is controlled by a computer that is monitoring the amperage and the voltage, it's very fast and very reactive. So the second that we get a short to ground, you're going to get an error code. Now in a PSC system, if you were to get to short to ground, you would almost pop that breaker immediately. So just understanding about how the VRP responds to those types of situations is going to point you in the right direction of maybe we should take a look at the motor, and then we should take a look at the board. So we're going to go over a couple of these diagnostic codes, and then we're going to go over how to troubleshoot them. So the amperage or current diagnostic codes is that the current sensing portion of the MCS board has detected that the motor is pulling more than desired amperage. So this could be a grounded motor, this can be a demagged motor, or it could simply be that the voltage or amperage sensing element on the MCS board has been damaged. So an I2T fault or an IPM amperage fault is basically the current sensing portion of the MCS is detected the motor is pulling the maximum allowable amperage for an extended period of time. So this is an indication of dirty coils or something where there is a restriction going on, that the motor itself is restricted, or we have really high abnormal temperatures, or just simply that the sensors on the MCS board are damaged. So voltage diagnostic codes is just very simple. The current sensing portion of the MC board is detected that the system voltage is abnormally high or abnormally low. Whenever you get a voltage or amperage related diagnostic code, now this could be to the outdoor fan or to the compressor, you probably want to check the motor before we go to the board, because the motor is the most easily accessible. Probing those little small ports on the board may not be the best way to troubleshoot this. So the easiest way to go about one of these diagnostic codes is to basically look to the motor and then prove that the motor is good, and then we can rule out the motor and say that it's most probably the board. So In going over those, let's talk about the compressor. So the compressor is attached to the MCS with flag terminals for easy access. With the flag terminals unplugged, you should get plus or minus 1 ohm between between any two phases on your compressor. So depending on the model, you might get 1.5 to 3.5 ohms on any two phases. And like I said, we're looking for equal across the board with a variance of maybe plus or minus 0.1 ohm. If you do happen to check the wiring and you do happen to get something that seems abnormal, at this point you want to go to the compressor itself and you want to probe those pins directly to make sure that you don't have a bad compressor wire. Troubleshooting the outdoor fan is just like troubleshooting your compressor. The outdoor fan, like the compressor, is a brushless DC motor. So troubleshooting the component is pretty much the same. So you want to ohm the connector at the MCS board first to see the resistance. So you want to unplug it from the MCS board, and then you want to back probe each one of those, each pair of phases to make sure that they're equal, plus or minus 1. And then you can check each phase to ground to make sure that you don't have a grounded motor. This is where your needle point meter leads are definitely going to help you, because getting into the back of those Molex sometimes can be a little bit of trouble. Same method as before. If you turn out you're getting some ohm values or some ohm readings that aren't consistent, you can go underneath the chassis and you can unplug the outdoor fan directly from the connector in the bottom of the motor housing, and then you can probe that Molex plug that directly hooks up to the outdoor fan. So when it comes to motors, the MCS board does have a lot of operational lights. So starting at the top of the MCS board, there is an orange LED that flashes at you to let you know that the 12 volt rail of the MCS board is operational. The next, you're going to see two small processors on the MCS board. These can be found at roughly 4 o'clock on the MCS board, and they're located near the 5 capacitor banks that are at the center of the board. So you can see I have them pointed out here in the slide. So processor A and processor B, these are the two processors that control the motors. One of the things about ruling out the board versus the motor is to see when you get a fault. So you can see here that I have a red LED above one of the processors. So this is telling me that that processor hit a fault when it tried to start that motor. So when that light shows up is probably a pretty good indication of whether it's the board or the motor. So a good example is when you start the VRP, if you see one of those lights lit and constantly stay lit throughout the sequence, and the light never disappears and the light never goes away, and it happens the second you turn on the MCS board, you could almost assure that there's probably something going on with that MCS board. So at this point, what you want to do is you want to rule out your compressor and your outdoor fan to make sure that both of those motors are good as far as their ohm values, and then you confirmed that it definitely is the MCS board in this case. Let's take a look at some of the voltage ampage related diagnostic codes. So I'm going to call out a couple important ones here. So let's look at error code number 32, the MCS compressor overcurrent. So you're going to get this error code when there's something going on with your compressor. Now, the important thing about troubleshooting an error code 32 is when you get the error code to populate. So like I said, if it turns out that you turn on your equipment and there is no call for cooling, there is no call for heating, and you get an error code 32, you can most probably assume that there's a short on the board, which is sending that code which is sending that code to the FMC, and there's probably something going with the current sensing element on the MCS board. Error code 36 is a code that sometimes populates when you first turn the unit on. What happens is sometimes the MCS bus voltage isn't fully charged before it engages one of the motors, and you might get a false code 36. This code should clear after a couple of minutes. If it turns out that the code doesn't clear, you want to turn your unit off and turn it back on, and then see if you produce the same error code. If you do, you might want to check your line voltage, because the MCS bus voltage is a good correlation to your line voltage. So you probably also have low line voltage. When troubleshooting compressor or outdoor fan I square T faults, it's the same thing that we talked about before. is that these components have been operating for their maximum capacity for a long time. So we want to figure out why those units have been operating on such high demand for so long. So the basis of the I2T fault, especially for the outdoor fan, is probably something going on with airflow. So if you're starting to get an error code 49, you probably want to take a look at your outdoor coil, and you definitely want to make sure that it's clean and that the fan is able to push the air properly through the coil. A couple of other ones that we happen to see in the field is error code 53 and error code 54. Obviously, these have to do with line voltage. So you can see here, if the AC voltage coming into unit is less than 187 volts or greater than 293 volts, you're going to get an error code 53 or an error code 54. The FMC, MCS, heater board, wall controller, and indoor fan all communicate via ribbon cables. So if communication is lost or dropped in any one of those, the VRP won't operate. And more than likely, it's going to populate an error code. So you can see inside the picture here, we have all of the connection ports for the communication. Let's start on the bottom for the indoor fan cable. You can see here it connects to the FMC at about 4 o'clock. There's a ribbon cable that connects the MCS board and the FMC board at roughly 3 o'clock on each of those boards. Obviously, we have the wall controller port that plugs into the green Molex connector in front of the unit. And then we have the heater board ribbon cable, which plugs into about 3 o'clock on the FMC board, and it goes all the way across and over the MCS board to the heater board all the way on the left. Before we get to diagnostic code 2743, we want to mention diagnostic code 40. So diagnostic code 40 is probably the most popular error code that we get, and that is when the VRP wall controller can't communicate with the FMC board. So whenever you get this error code and it's 4 blue flashes and a pause, you definitely want to check your field wiring to make sure that that you have a good connection on both ends of the VRP and the wall controller. So once you verified that, the other diagnostic code that we're going to go over here is error code 2743. So more than likely, if you get an error code 43, it's also going to populate an error code 27. So error code 27 basically means that the FMC can't find the heater board. It can't communicate with the heater board. And an error code 43 means that the FMC can't communicate with the MCS board. So by nature, if you get an error code 43, you're also going to get an error code 27. If it happens that you get both an error code 27 and a 43, the first thing you're going to look to is the FMC to MCS ribbon cable. So a couple of quick steps that you're going to do. The first thing is you're going to take a look at your heater board, and you're going to verify that you have a green light on your heater board. Having the green light on your heater board, you can most likely assume that the cable that connects the FMC and the heater board is pretty good. So this is where you want to look to your FMC to MCS ribbon cable. So probably first step you want to do is you want to unplug that cable, and then you want to plug it back in and restart the machine. If it turns out that the code goes away and the machine starts fine, that's probably an indicator that that cable has started to wear, and then you wanted to replace that cable. So error code 39 is a pretty tricky one. And I think before we get to error code 39, there's something that we should go over the specifications or the specifics of the indoor motor. So the indoor motor has 2 connections to it. It has a line voltage side, and then it has a communication side. So the power side is your L1, your L2, and your ground. And then the 4-pin communication side is your 10-volt, your signal to your fan, your ground, and then the tack coming back from the fan. So whenever you get an error code 39, you want to start with your power side. So you want to confirm that you have good voltage going to your indoor fan. And once you confirm that you have good voltage going to your indoor fan, then you want to tackle the communication side. So how to troubleshoot this one is the first thing you want to do is set your meter to DC voltage, and you want to take your black probe, and you want to bury it inside the ground terminal. Now, the indoor fan produces 10 volts DC, and that's found on the brown cable. So on your red meter lead, putting it or back probing that Molex connector, you should see 10 volts or something close to that, 9.9, 9.8, 10 volts coming from that brown wire. If the fan is running, you should be able to take your red probe and move it over to the blue wire, and this is the tack coming from the fan. And what you should see is something like 1 to 5 volts DC. And this confirms that the fan is sending the proper, that the fan is producing the proper voltage and sending it back to the FMC board. Now, the next thing you want to do is you want to take your red probe and you want to put it inside the yellow port. And what you should see is something like 1 to 5 volts DC coming from that port. If you see 0 or if you see 10, you could assume that the FMC board is not producing the proper signal. If you do happen to see this situation, you want to turn the unit off, wait until it shuts down. Then you want to power the unit back on, and you want to leave your red probe inside the yellow port. And what you should see is you should see the DC voltage rise from 0 to 10 over time. If you don't see that voltage rising as you have your call for indoor fan, then you can definitely say that there's probably something going on with the FMC board and you want to replace it. If it turns out that that test does work, you want to you'll do the same test to the blue wire and make sure that the voltage is going up and ramping down with the speed of the fan. If it is not, then that's the point that we want to replace the indoor fan. So going over the communication and configuration diagnostic codes, starting with the error code 27, which we went over with earlier, this is when the heater board is not communicating. So in order to troubleshoot the heater board not communicating, we want to verify that that green light is on the heater board. If the green light isn't lit, then there's probably something going on with either the board or the cable. We want to troubleshoot that and rule out the components, right? So we want to swap the cable, and then if that doesn't work, then we definitely want to swap the heater board. So if the green light is on, there could be something going on with the MCS board or the FMC to FMC ribbon cable. So, but you could try unplugging those and replugging those in, and then ensuring that you got proper power to your MCS board. So if it turns out after all those steps, if you can't get the error code 27 to clear, you might have a rare situation where we call that the FMC has not been provisioned correctly. Now, if you did have this, you might get in conjunction with an error code 34. At this point, you want to contact us, and we'll go through the rest of the steps about how we can troubleshoot with you and how we get that piece of equipment online. So we already went through an error code 40, which is the wall controller not connected. This is when the FMC can't pick up the wall controller, so we definitely want to check the wall controller wiring. And then the error code 43, which basically means that the FMC cannot communicate with the MCS board, which is that ribbon cable that connects the two of them. That wraps up our slides on diagnostic codes. It's important to remember to have patience when working on the VRP and keep your refrigeration theories and methods close by. On those tough situations where you need additional support, our VRP technical management team is here to assist you through these issues. At Friedrich, each manufacturer's rep agency is assigned a technical manager by state. I'm sure many of you has experience working with someone from our team, but we'll show you the territory map here in a few. We can be reached either by phone or email, and our team email address is vrpsupport@friedrich.com, and don't forget the underscore between VRP and support. When you send us an email, be sure to include the property, location, equipment info, and complaint and error codes. It would be helpful also if you would include the steps that you've taken to troubleshoot the unit. Now, at times, the technical manager may ask you to pull the unit's data and send it to us, and we'll cover that next. If there is a time where you have a contractor on site needing assistance and you are unable to assist them, they're welcome to call our Technical Assistance Center and speak to an agent. We'll show you guys the contact numbers at the end of this presentation. If there is a time when we request a data file from you, the VRP does store all of its operating procedures and values on the SD card on the FMC. So in order to send us the data, simply power down the VRP and take the SD card out of the FMC, and you want to put it into a PC or laptop through an SD card reader. So once you open up the file structure, you're going to look for the folder that says DF. Once you open this folder, you're going to notice that there is a text file in there, and that's the file that we're going to need. Depending on how long the VRP has been operating, there might be 2 files in there. If there happens to be 2 files in there, we're going to want them both. So here's an example of that data file that's in there. And what you want to do is you want to zip that file up. So right click it and then open up the option that says send to and then compressed zipped folder. And what it's going to do is it's going to compress this text file into a size that you're going to be able to email. So some of the files that you can get on the VRP that can get pretty well north of 200 or 300 megs. So you're not going to be able to email that to us. But when you compress it and zip it down, it gets to roughly 15 or 20 megabytes, which would be good for some email. If it turns out that you can't email it to us, you can always put it inside a cloud service such as Dropbox or OneDrive, and you can send us the link, and we would be able to access it that way. Either way, when sending us the VRP data, you're going to have to give us the room number and the site location and the date that you pulled the data, so that this way we can properly analyze it for you. So once you have all this, this is when you want to send it to our VRP support email, which is VRP_support@friedrich.com, and make sure to note the chief complaint that you're dealing with. Here's an example of an email here. So you can see that the participant is sending us one of the data files. It's such a small data file that he was able to attach it directly. This isn't going to happen most of the time. You're probably going to have to zip that file up and send it to us. So you can see here that they currently have an issue with 2 rooms at the property, and what they've done is they gave us the model serial number, the room that the unit is located in, and then what they observe as far as an issue with the unit. So this is pretty standard for what we would like to see when we get the email requests with the data files from you guys. So this way we know who to communicate back with, and we also know what to look for. So giving you guys a quick snapshot of the VRP technical management support team. We are made up of regional technical and area technical managers spread out throughout the country to give you guys support based on region. So depending on which state that you guys are in, that is the technical manager that you're going to contact via email or by phone if you do run into some pretty serious problems. So no need to write down the phone numbers or to screenshot them. We're going to share this presentation with you guys afterwards. Here's a quick snapshot of the VRP technical management support team. So we have Jeffrey Craig, who runs the U.S. Region. We have Justin Patton, who runs the Central and the Mid-Atlantic region. We have Chris Palmer, who runs the Southeast region. And then we have Steve Lloyd, who is the area manager that oversees the Mid-Atlantic region. I myself am the director of the team, and I am currently interning to help to run the Northeast region. So the technical management team can be reached for VRP support at any time by email by contacting us at VRP_support@friedrich.com. If you guys if your contractors get into a jam and they need somebody to talk to immediately, we do have our TAC center that they can call into, and that they would get immediate help. So the TAC assistance toll-free number is 877-599-5665, and they want to make sure that they get to extension 3113. If you needed to email them, their email is tac@friedrich.com. I'd like to thank everyone today for joining us. I hope that this was very informative for you guys, and now we'll start our Q&A session. Back over to you, Jared.
All right, thanks, Pete. Great presentation. Fantastic short deep dive on our VRP technical troubleshooting. I appreciate your time today. Just as a reminder, as we enter Q&A, the easiest way to get a question submitted is to move your cursor over your Teams screen, and when your icon menu box pops up, you'll see one that says Conversation to the right side of the screen. You can click on the meeting chat, enter a question, and I can get that submitted to our Friedrich VRP team for answers here at the end of our webinar. While we wait on some questions to be submitted into the chat, just a reminder to like, share, and subscribe to Friedrich on social media. We are on Facebook, Instagram, Twitter, and YouTube, and we are updating content seemingly almost daily on our 4 social media outlets. So please like, share, and subscribe. Mr. Adachi and Mr. Cotner, we have had a couple questions get entered. One I've already answered in meeting chat from Clayton. How can we see the videos of this training? And as my response in the chat, our videos are going to be uploaded on our private YouTube channel, and a link will be required at the conclusion of our training sessions, which today is our final scheduled one outside of our ductless technical troubleshooting. We will create a list of all of those links, and we will be sharing them through our rep channel as well as providing them to everyone who attended. I would anticipate that you should have all of those links within the next 2 weeks. However, those links are also dependent on me doing my work and getting them typed up and sent over. So bear with me, but we will get them over. I appreciate the question, Clayton. We are excited to share all of them as we have been recording them for that purpose. Pete, question from Mr. Mobley, sorry, Swenson. Can you go over again what you were talking about as in hooking up the gauges to the VRP?
Absolutely, Jared. So Swinson, so we said that the VRP is critically charged. So it's very important that we make sure that we have a supposition that that the charge might be faulty or there might be a restriction before we go and hook up gauges to the VRP. So let me just throw a really quick example at you, is that you're getting a high pressure switch activation, you're getting an error code 14. That's probably a good clear indicator, obviously, that there is something going on with the charge. So at this point, you most likely would want to assume a set of you want to put a set of gauges onto the VRP to rule out whether that the pressure switch is bad or if there's a blockage, or basically diving into why that unit is tripping off of on either high head or low pressure. I hope that answers your question, Winston.
Hey, Pete, this is Bascom Swinson. Let me piggyback off Pete's comment there. Error code 14 can indicate, as Pete said, either high head pressure or low pressure. There's some environmental things you can take into account to kind of infer what's going on. For example, if the unit has been off for 5, 10 plus minutes, and you still have an active error code 14, or you walk into a room of a complaint with the unit not running and 14 is active, that's typically a very good indicator that it's low pressure. And as Pete said, it's critically charged, so we want to be very careful with those gauges. It's also useful to keep in mind that this is a variable speed piece of equipment. So you may not get the same kind of readings you get when putting gauges on your single speed systems, that you're used to seeing a range between X and Y on the high end and a different range on the low end. It'll vary widely. Typically on these units, if they are off and error code is not 14, they tend to balance out the high 100s, low 200s on both sides. But most of the time you can infer what's going on with the charge based on error code 14 and what the unit's been doing over the past hour or so.
All right, thank you, Bascom. Thank you, Pete. Just while we wait on additional questions, a reminder, if you have a question, move your cursor over your screen and the Teams menu will pop up. All lines are on mute, so audio questions are difficult, but if you click on the conversation box, that will open up the meeting chat and you can simply enter a question there. Guys, one just came in from Chris. I came in a little late to the webinar. I have some troubleshooting to do in the morning with some EEVs. Any insight on troubleshooting EEVs?
Sure, Jared. Troubleshooting an EEV, obviously we're going to look towards port performance, right, or node performance at all. Probably the first step that you would want to take is just to make sure that the EEV is properly seated on the valve, make sure that it's locked in, make sure that all the wiring is good, that the EEV is plugged in. After that happens, when you turn the unit on, you should hear a series of clicks coming from the EEV, and that's the unit getting a center position or getting a calibrated position from the EEV. So one of the things that you should hear is a series of clicks and turns. Now, if you only hear clicks, but if you only hear clicks and you don't hear turns, that means that there probably might be something going on with the EEV valve body. And if that's the case, the only way you're going to determine that is by letting the system run. And what you should probably get is a error code 14 for basically high head pressure, because since that EEV is closed shut, that your compressor is going to build pressure. and it's not going to be able to circulate it through your refrigeration system. So, checking out the wiring, making an audible check to make sure that you're hearing the valve open and close. It sounds a little bit of like not like a grinding, but it sounds like you can actually hear the solenoid turning the valve. And then if you do hear that there is no clicks, there is no turns, you might simply just have a bad EE valve head. And then obviously if there's any sort of fraying or any sort of compromised wires or unplugged or not properly seated plugs, you would get that symptom as well. Hope that answers your question.
All right, thanks, Pete. Thanks, Chris, for the question. Doesn't look like we have any more coming into the chat. I will leave it open just as a reminder. If you have a question, simply move your cursor over the screen. Your menu box will pop up. That should enable you to select on conversation, which opens the meeting chat, and you can enter a question into our meeting chat. I will leave it open for another minute here, but want to say thanks to our presenter, Pete, as well as Bascom for joining today and answering some Q&A. Great job, guys. And want to thank all of our customers, our rep channel, as well as owners for attending today's VRP troubleshooting webinar. We appreciate your time. We certainly appreciate your business. Thanks and have a fantastic day. Pete and Bascom, if you'll remain on the line for 1 minute, just if we get a late question, that would be great. Otherwise, thanks everyone, and thanks for attending.
Thank you, everyone.